Okay, this is differentiation packet 26B, and this is question 2. We're doing a little bit of practice on linearization. So you'll see I've already written down I guess you could call it the third form of the linearization formula or the linearization equation. Essentially what we're doing is finding the slope at a certain value. In our case, we're going to be finding the slope at 1. And we're going to create a tangent line at 1, and we're going to use that line to estimate the actual value at another point, in this case 1.1. So we can see all these little parts. We know that our a is 1, so right away I'm going to put a 1 here. That's going to be under our a. We want to know what f of a is. Okay, so off to the side, if f of x is x squared plus 3, then I know f of a, being 1, is going to be 1 squared plus 3, which is 4. Okay, so this is going to be a 4. We know that the place that we want to approximate is at 1.1. That's what it says here. So my x is going to be 1.1. And the other thing that I need is f prime of a. So if f of x is x squared plus 3, we know its derivative is 2x. So then the derivative at 1 is 2 times 1, which is 2. Okay, so the derivative at a being 1, is 2. And all of this is going to get me what I want, which is going to be f of my x, which is 1.1, right? So what we really got on the right-hand side is the tangent line equation at 1 comma 4, right? So the point is 1 comma 4, and at 1 comma 4 the slope is 2. So that's what these pieces are. So there's your x and y coordinate, and that's the slope. And now we're going to use that tangent line to approximate the height at 1.1. Okay, so we do out the math here. This is going to be 2 times 0.1 plus 4, so that's going to be 4.2. The second part asks, is this an under or over approximation of the exact value of 1.1? Well, we could figure out the exact value, right? This really should be an approximate. But the exact value of 1.1 is going to be actually using the real function, x squared plus 3. So 1.1 squared plus 3, we grab our calculator, and that's 4.21. Okay, so this is the exact, this was our estimate, so our estimate is an under approximation of the actual, right? So what I'm guessing is that the curve, well, we know this curve looks like a parabola up 3, so something like this. And if you think about a tangent line, that tangent line is going to be underneath the actual height of the curve, so that makes sense.